Assalamualaikum, my name is Zoha, name roll number 21TE01, and today I will be discussing Lab 2 of Digital Signal Processing, that is basic plotting of signals using MATLAB. In task 1 we are required to simulate a unit step function. Here we have taken n0 as the starting point for our function and n1 and n2 are the boundary points. Vector n is generated using n1 and n2 and the output x will only be 1 when n minus n0 is greater or equal to 0. In task 2, we are making a unit step impulse function and we have taken n0 as a starting point for our function and n1 and n2 are the boundary points. Vector n is generated using n1 and n2 and output x will only be 1 when n minus n0 is equal to 0. In task 3, we are required to generate a decaying exponential function. We have used the previous technique of generating the vector and x is the exponential function. For part B of task 3, we have generated a sinusoidal signal using the previous approach. Here we are asked to design a function that can generate a unit impulse function. You can simply call this function using command window. Now we are asked to design a function that can generate a unit step graph. You can also call this function using the command window. The task 6 requires us to use the functions created in tasks 4 and 5 to create the graphs of the given signals. You can simply call the previous function and assign the given signal equation to x, and using the stem command we can get a discrete graph. This is the second part of the previous task and can be done in the same way. In the task 7 we are required to flip any given input signal. This can be done using the flip command that is built-in command in MATLAB. For task 8, we are doing index scaling. Here we are required to have a scaling factor and then we multiply the indexes of the original signal by that factor and plot the results. In task 9, we are shifting the original signal. Here we have a shifting factor. We named it as shift amount and then using the function of circular shift, we have shifted the indexes. In task 10, we are required to have zero order hold simulation. A continuous and signal continuous define a continuous time signal and its corresponding time vector. Ts specifies a sampling period for the discrete time signal. T discrete defines the discrete time instances based on the sampling period. Signal zero order hold initializes an array for the zero order hold simulation. The for loop iterates over each discrete time instance. For each instance, it finds the latest continuous time index before or at that discrete time. The value of the continuous time signal at the found index is assigned to the corresponding element in the signal zero order hold. Two subplots are created using subplot to show the continuous time signal and the zero order hold simulation. In task 11, we are required to have the first order hold simulation. T continuous and signal continuous define a continuous time signal and its corresponding time vector. Ts specifies the sampling period for the discrete time signal. T-discrete defines the discrete time instances based on the sampling period. Signal first order hold initializes an array for the first order hold simulation. The for loop iterates over each discrete time instance. For each instance, it finds the latest continuous time index before or at that discrete time. The code calculates interpolation coefficients based on the relative position between the discrete time and the two closest time samples. The value of the first order hold simulation is computed using linear interpolation between the two closest continuous time samples. Two subplots are created using the subplot to show the continuous time signal and the first order hold simulation. Here we have the output of the first order hold simulation. Now we will discuss the difference between zero order hold and first order hold. These both are the methods that are used to convert continuous time signals into discrete time signals. Firstly, we will discuss zero order hold. It holds the value of the continuous signal constant over each sampling interval. It results in a piecewise constant discrete time signal. It is simple to implement computationally. It can introduce step-like changes and overshoot. Now, for the order hold, it uses linear interpolates between consecutive samples of the continuous time. It results in a piecewise linear discrete time signal. It is slightly more computationally complex than zero order hold. tends to produce a smoother output as compared to the zero order hold. It has a frequency response proportional to the sinc squared function, that is suppressing high frequency components more effectively. The choice between zero order hold and first order hold depends upon the application and the desired characteristics of the discrete time representation, with first order hold often providing a smoother transition between samples. Thank you so much for watching.